4 billion years of evolution have given us legs, and they enable us to walk across and move across very challenging terrain and very varied terrain.
If you look around us, it would be hard to drive a cart up this, right? These big boulders and sand intermixed, but as a legged being, as we are with humans, we can step around it easily, as a dog could walk around it easily.
And so this project is the proving ground that we can enable new science and new mobility on environments that are like other planets.
LASSIE is a project that is supported through NASA's Planetary Science and Technology through Analog Research program. This whole program is designed to get together engineers and scientists to run operations in environments like this one here at Mount Hood to test what we might do on other worlds. Lunar exploration is right around the corner. We have plans in the next 5 years to be on the surface of the moon with humans and robots.
And so one of the major points of this project is how can we use a team of a person and a robot and have them work together in the safest and best way.
So the robot is called Spirit. So it's a dog-like robot, almost dog size actually, and moves like a dog. It can do a little trot, it can do a little bit walk and a little bound.
As the robot is walking, it can actually feel whether the soil under it is giving way and it's sinking, or whether it's very strong and it can walk on top.
Similar to the way that when we walk on uneven surfaces as humans, we can sort of detect how the ground is shifting beneath our feet, a legged robot is capable of the exact same thing.
And so they're not only able to change the way that they walk in order to move across that terrain, but they can also learn about the behavior of that soil or that ice or that material underneath them. The legs enable a new kind of exploration and a new kind of scientific learning.
So we have a real dog on site, Howard, and we're going to observe how Howard moves on different type of snow ice condition. And then we're going to say, okay, so what exactly of those combined motion allows him to succeed on challenging terrains that maybe currently our robot will slip, will fall over. We're trying to see, okay, can we make some hypothesis on it might be this, right? It might be the foot morphology. It might be the speed when you touch down. It might be the angle when you touch down. And then we're going to test that systematically in our robot. And that will allow us to make way better future robots that will be inspired from the animals' mobility.
Space exploration is intrinsically a multidisciplinary problem, and it requires people from all different disciplines, from science, engineering, construction, behavioral science, and this project is integrating all of those.
These grand challenges that we face as a human species, they're not going to be solved by a single discipline. It's going to take people with different sets of training, with different perspectives, coming together for us to make progress on these complicated things like human-robot teaming for planetary exploration.
It's important to realize that the ecosystem that is space exploration is significantly beyond just NASA. We're leveraging the best researchers in their field from the different universities, students from undergraduate to graduate level to postdoctoral level.
I am currently a student intern on the Curiosity rover, and there are just areas where we cannot traverse because it's too steep or unstable for the wheels to go over. So knowing that there are possible future missions which we can have legged autonomous robots out there traversing across areas that we couldn't even dream of going before is amazing to me.
So I think that there are existential questions, and they trace us all the way back to really, the deepest questions of why are we here? How did we get here? And so there are really deep aspects that humans have always been driven to explore and go to the next frontier.
There's a chance to understand something new, to do something new, to improve, to push on the human knowledge boundary, embracing the unknown and making new discoveries, and learn from every failure that we encounter here and turn that into huge success.